Hello everyone, and welcome to this Telit Cinterion webinar, How GNSS Modules Achieve Higher Precision and Why It Matters. I'm Amanda Flink, the Head of Global Events here at Telit Cinterion, and I will be moderating today's event. First, I would like to thank Swift Navigation for joining us today. To explain this topic, I am pleased to be joined by two speakers. First, we have Gianmarco Zanda, Project Manager of GNSS at Telit Cinterion. And second, we have David Huntingford, Staff Product Manager at Swift Navigation. Now, just before I hand it over to Gianmarco to start our presentation, I do have just a few quick reminders for our audience. We will have time to answer some questions at the end of our presentation. You can simply submit a question by posting in that questions box, which will be located near the bottom of your screen here. Also, please be sure to check out the resources section for some additional information. And finally, we will send out this replay link to all attendees at the conclusion of the webinar. And with that, Gianmarco, I will hand it over to you to start our presentation today.
Thank you, Amanda, and thank you, Dave, for joining. And hello, everybody. I will be presenting today this webinar together with Dave. The agenda will be a brief introduction on the improved precision and accuracy, and then the results of performance we can achieve with Telit product and Swift Nav services together. First of all, a brief overview of Telit Cinterion, how we changed in the last few years, where we have now three main pillars of the IoT world. That would be the edge, the network, and the cloud. We are now a full IoT solution provider. We are able to combine all these key ingredients to provide unparalleled support and services to our customer, starting from the module side, more hardware related, that was historically our business, then moving to the connectivity world as being a global IoT MVNO, including activation services for the SIMs and our new Next and Next Plus services. And then on the cloud side, our device management portals, middleware platform, and enterprise integration services that we provide. In this portfolio of products, I am product manager for GNSS. So today I will focus on how the GNSS modules, together with our connectivity and our cellular module, can work together with the Swift Nav service to achieve higher precision. And I think I can hand the word to you, Dave.
Okay, thank you, Gianmarco. Great introduction there. So maybe a little bit of very quick overview on who Swift are. We are based in San Francisco. We have regional offices around the world, and we provide GNSS corrections that help improve the accuracy of GNSS positioning. So we have coverage in North America, Europe, Australia, Asia, and we're continuously building out our network. We've been in business around 10 years, and we currently have over 10 million vehicles and devices that connect to our server every day. Okay, next slide, please. Okay, so our solution provides universal precise positioning, and you can see in this diagram we have our cloud-based service in the middle, our Skylark positioning service. Through that solution, we provide to the device, which can be asset tracking, robotic lawnmowers, GIS survey, or automotive. There are many verticals. Each one of these devices, when it's equipped with corrections from our cloud, can bring the accuracy to decimeter and centimeter level. So this technology is applicable over many verticals, and we see pretty good market adoption now of corrections to help improve accuracy. In fact, there's a saying that higher accuracy is addictive, and we generally find that true when people start to see higher accuracy, they realize there are new services that enables to be run on top of the devices. Okay, next slide. So just a very quick view of some of the areas where we see the corrections being used. A good example is map creation. That used to be static. It was manually created, maybe from photos or satellite imagery. And now it can be dynamically crowdsourced from cameras in vehicles. But in order for that to happen efficiently, you need decimeter or centimeter positioning in the client device. Vehicles shifting to full autonomy, equipment becoming robotic. Lawnmowers is a great example. Where I live in Phoenix, Arizona, we now have Waymo cars that are driverless. And we also have some food delivery robots that can come by. And every one of these is using high precision GNSS. Delivery, last mile, final yard. Again, more ways to make these industries more efficient. And mobile applications, fully immersive augmented reality. In order for that to work well, you need really good positioning. So the message here is that although corrections came from an agricultural kind of background, the RTK development, what we see is adoption across many different verticals with newer, more efficient use cases relying on corrections. Next slide, please. So put visually, standard GNSS, it'll put you on the street, but it's not really going to put you exactly where you are. And when you look at this visual representation of the difference between meter level and decimeter level, you can see this would tell you, which lane you're in, which corner of the street you're on. Later, we're going to talk about micromobility and scooters, knowing exactly where the scooter is and where it's being dropped. These are very useful use cases, both for the consumer and the enterprise. Okay, next slide, please. All right, so a little look at delving into the technology. The sources of errors for GNSS satellites. So the satellites themselves can have clock and orbit errors. That can add in a couple of meters of errors in itself. And then there are distortions that occur through the ionosphere and troposphere. The ionosphere is particularly active currently. We see the northern lights, really good shows in lower latitudes. And when those conditions happen, you see stronger distortion of GNSS signals. And then at the lowest level, there are environmental impacts such as multipath, signals being reflected, or obscuration. Okay, next slide. So what our service does is, through our ground infrastructure, we monitor the satellite clocks and orbits errors. We also monitor the ionospheric and tropospheric distortions. We bring the data from our ground infrastructure up to our cloud, and then we model in our cloud all of these errors, and those corrections can be passed to the devices. So I'm going to hand back to Gianmarco to start to talk about the devices.
Yeah, as you can see in the picture, we are two of our products that will be the SE868K5-RTK, supporting RTK correction, and the SE868SY-D that supports DGNSS corrections, both provided by Skylark engine, as I will present and show better in the next couple of slides. Are a clear example of how these corrections can be applied to real case and IoT devices, not only so on the automotive side, but also for the what Dave was mentioning before, the last mile, or the smart robots, the lawnmowers, and all these applications where this extra help with the accuracy can be additive, and I tend to agree on that side because we also started to test the performance of the service and with this module, and we really see that there is a real interest from the customer side. Back to you, Dave.
Thank you, Gianmarco. Okay, so a brief slide about the quality of our service and the implementation. So our Skylark cloud-based modeling, it allows us to have 3 nines, that's available as an SLA. We host on Amazon, that allows us to have a lot of nice features like the automatic load balancing, the failover, and we also have proactive monitoring of our stations. And then within our cores network, we defined the exact implementation of our reference stations. They all have a very high quality dual geodetic grade receivers. They have power backup. They also have failover hardwired as well as modems with dual SIMs. And we maintain these with our mobile network operator partners who are very well akin to understanding how to operate carrier grade services. So by working with large MNO partners such as Deutsche Telekom, that allows us to roll out a carrier grade service for the provision of corrections. Okay, next slide. So taking a little bit more look at the services we're going to be talking about today. We actually have 3 levels of service. On the left-hand side, Skylark Dx is our DGNSS service. We headline that as a submeter service with quick convergence, and it's ideally suited for small battery-powered devices such as asset trackers, mobile phones, wearables. We have a wide area RTK service in the middle, which today is not supported by the Telit module. So for now, we're not going to be talking about that. And on the right-hand side, we have our Skylark Nx RTK service. This is a 2 centimeter regional service. Convergence speeds are fast because we have ground infrastructure. The corrections have very good low residuals. And this is perfect for devices needing centimeter accuracy. And those are things like industrial equipment, outdoor robots, and Gianmarco is going to walk us through some really good examples that show just frankly how amazing the accuracy is you can achieve with RTK. He's got some really cool toys to show. Okay, back to you.
Thank you, Dave, for the presentation on both on your service and also on the errors and how the corrections can help. As anticipated in the previous slide, we have got 2 Telit Cinterion modules that are fully compatible with the Skylark service. The SY-D is targeting larger IoT and e-mobility deployments, especially. It works flawlessly with Skylark Dx, targeting submeter accuracy, while our newest product in the portfolio, that is the SE868K5-RTK, is able to achieve centimeter level accuracy for, I would say, all the specialized markets like the outdoor robot. So on one sense, I believe it will be a little more niche market, but as we anticipated, there are a lot of applications where the accuracy and the higher precision is really needed. So we really see an opportunity to present a product that satisfies our customers in this kind of needs. So the workflow of the corrections on how this correction works with our product, well, it's explained in the next slide a little more easily. If you see, so let's say that if this is the Skylark cloud service, correction service, and this is our products that can be installed in any device or in any either in any application our Telit customers in different verticals are interested in, but we highlighted here more the drones, the robot, and the e-mobility, as we previously mentioned. The GNSS modules receive the standard signal from the satellites and achieve a rough position with, let's say, with standard accuracy. This standard accuracy position is sent back to the Skylark cloud service that replies with a stream of corrections related to the area where the device are, and these corrections are injected to the module that then can return accuracy position fix. That can be either submeter or centimeter, depending on the module. Just to highlight here that this communication between our GNSS modules and the cloud here is represented by one of the Telit, our LE910 C1WWX module that is able to integrate an N-trip client that can directly communicate with Skylark service. And we have a demo app can be installed in these modules and other, let's say, compatible cellular modules for evaluating the service directly with, including cellular side, GNSS side, and also Telit connectivity that can help in that. Sorry, in this process. So the target or the final method will be to simplify the higher accuracy implementation with I would say a complete solution from Telit side with the support of SwiftNav. And in that sense, we've got the SE868 family that with a single design with a compatible footprint GNSS can be scalable from a standard dual L1 L5 module that is based on a Sony chipset supporting DGNSS to I would say more specialized and more dedicated also dual band module based although on the Iroha AG335 platform supporting the RTK. So with one design, customer can decide to swap from submeter or centimeter level positioning accuracy. The solution is both of the module are already certified for Europe with the EUTech Red. Of course, that streams and speed up the time to market, and with the support of the cellular connectivity, both on the module and on the, I would say, on the connectivity itself side with the SIMs. So we are able to allow the customers to test this solution immediately. Few considerations on the service. So that the GNSS use phase code corrections. I don't want to spend, let's say, too much time on the technical background because that is not the reason of this webinar. Is more to show the customer what we have and what we can do together. But let's say just to give you a highlight, so the RTK use the code phase and the carrier phase corrections. Since the carrier phase correction, the measurements are typically order of magnitude more precise the code phase, it is understandable how we can move from submeter to down to centimeter level accuracy. So as I will present in the next, let's say, result slides we have, the RTK corrections provided by Swift navigation allows the SE868K5-RTK to achieve centimeter level accuracy, I would say, with clear signal. While DGNSS corrections, although they are limited to submeter accuracy, I would say they've got a broader application and broader coverage. So in absence of clear signal, for example, the RTK suffer some, I would say, some degradation of performance that is expected due to the technology and the target. But the message here is that we have a solution that can fit depending on the customer need. So if a customer needs a submeter accuracy, and we can help them choosing the SE868SY-D, or if they need a more specialized, a more accurate solution, there are some use cases or some, let's say, approaches we can suggest to achieve centimeter level in the majority of the situations. Briefly on the two modules, the SE868SY-D is in a compact form factor. It embeds an LNA for optimal performance. It is, I would say, it has flexible software that can be configured and tuned. Configuration can be saved. And it also supports multiple low power consumptions profiles that can be defined by the customer. And in addition, we provided it with 2 hardware variants depending on the target power consumption, with a standard one at 1.8 volt and another one with additional power reduction using 2 power supplies, one at 1.8 volt and the other one at 0.8 volt. In addition to that, I would say that the SY-D is also able to output the RTCM messages if customer has the interest in, let's say, develop the application or process the raw data on their end. It also supports server generated and locally generated prediction for fast time to first fix, jamming rejection, jamming detection, and also some anti-spoofing capability recently added to the latest software release. And as highlighted here, mostly targeting fleet management, asset tracking, and telematics and wearables market. While on the SE868K5-RTK, this is as well a dual band multi-constellation GNSS module, on the band L1 and L5. It shares the same compact form factor of the SY-D variant. It embeds an LNA for the optimal performance and also preselection soft filter to reduce the interference and best coexistence with other radios. Is similar to the previous one. We believe it is among the market, is among the one of the optimal trade-off between performance with RTK, especially RTK performance and power consumption at around 70 milliwatt at 1.8 volt power supply. This is also targeting the same power supply as SY-D. Well, in this case, a second power supply still at 1.8 volt can be applied for maintaining the clock and retain the RTC of the module. Again, sorry. Next slide here that I will hand over back to Dave about your specification of the services.
Okay, thank you, Gianmarco. So a quick look at our Skylark Dx, which is our DGNSS service. This is an IP-based delivery solution, so it would typically come over a cellular modem. Because it's DGNSS, it's very small, efficient packets. And we support GPS, Galileo, and Beidou, L1, L2, L5. Any compatible receiver, that means receivers capable of receiving the MSM1 RTCM messages that are tuned just for DGNSS. There's no RTK content in there. The interface to our server is Ntrip, which, as Gianmarco has described, that is a utility that can run on the host processor or within the modem module. And we support the most common global reference frame. And we have various standards that apply for security. Typically, that's more critical for safety of life applications in automotive. So we have good coverage, US, Canada. The Canadian deployments rolled out with our partner TELUS. We have European coverage with our partner Deutsche Telekom. We also have coverage in Taiwan, Japan, South Korea, and Australia. So this service has truly continental coverage, and it's uniform performance throughout the coverage area. It doesn't matter whether you happen to be near one of our stations or not, because it is a modeled solution. The performance is completely linear within the coverage area. Okay, back to you, Gianmarco.
Thank you, Dave. And let me show an example of the performance of our module with your DGNSS service. This particular test case is reflecting what could it be, let's say, an e-mobility parking lot use case, where the customer or let's say the e-scooter needs to be parked in a very specific stall, being parked outside could cause a fine or be a kind of be charged with extra cost on the company managing this e-scooter. So we georeferenced a precise point at the center of 1 meter times 1 meter square, and we tested two modules, one support use without DGNSS correction and one using your Skylark Dx corrections. And as you can see, these tests have been performed in parallel to demonstrate that only with the DGNSS feature, our module is enter and remain within 1 meter accuracy square. This is, I think it is important to consider that this is a cold start test. So it means that the module didn't navigate before, didn't have any kind of information. And so the accuracy, I would say, of the first fix could be that, like it's normal for GNSS solutions, standard solution is not the best at the beginning. Although in a, let's say, in the long term, in a standard, let's say, long test, even the standard solution will converge to the more accurate position in a reasonable time, I would say, for a customer use case. Only the support of DGNSS can really achieve that. And if you see that from the start, the module moves, or let's say the accuracy or the position improves towards the real position at the center of the square. And after 35 seconds after acquiring a DGNSS fix, so once the corrections are applied and the module achieves a fix, within 35-40 seconds, the module starts to enter into the square and remain there for all the following time. So I would say it is important to clarify also that. So this is not immediate, but 35-40 seconds is a cold start condition. In an optimal condition with best, let's say, if the module was already navigating, this time will be quite faster than that. So if you see in these two graphs, we say what the average error is, or how the error is behaving during the first test and during this couple of minutes, and you can see that the position average towards 1 meter, but roughly, so the error average around 1 meter, but it's peaking at 1.8 meter, even above 1.8 meter. While with the DGNSS, although the first position, that can happen because there are different conditions at the start, but let's say although the first position is not precise, within less than 40 seconds, we've got a module that achieve 0.5 meter accuracy and maintain this accuracy for all the tests. Getting back, so getting back to you, Dave, for comparing the performance on your side.
Okay, thank you. So this slide, I put this in here to answer a frequent question that we get, which is, well, why is the Swift DGNSS service, why would I use that when SBAS provides differential GNSS data. And so specifically what this test did is it ran a 50% sky obscuration. This was emulating a use case where it might be on the side of a shipping container as an asset tracking tag. And we're showing the percentile as the vertical axis, and then the meters of accuracy across the bottom. And you can see that the lowest performing is with no corrections, as you would expect. The mid-level performance is SBAS only. And then we're showing our DGNSS service, where we've slowed it down to one set of updates every 10 seconds and one set of updates every 30 seconds. So there's a couple of key things to draw from this slide, which is that DGNSS, when it comes from a service that has ground infrastructure in country, it will outperform SBAS, because SBAS is a very coarse DGNSS service. Really, SBAS is optimized for real-time integrity for avionics. And the DGNSS service is not, it's okay, but it's not as good as something that's coming from ground infrastructure. The second part that's key thing on this slide is we're showing that you can slow down the data rate. So if you have a Cat-M type modem and you don't want to send a lot of data, it's okay to send the corrections every 10 seconds or 30 seconds and still achieve good accuracy. So the table there really shows how shifting from SBAS to DGNSS at 10-second interval, a good doubling in accuracy. Okay, so next slide. This slide is again comparing SBAS with DGNSS, Skylark Dx. And the point here, this is full open sky, 24-hour test. And you can see that like at 95%, we're at about 2.5x improvement in accuracy. So it's really, you know, there is a good improvement by bringing in DGNSS and not just relying on the SBAS service. And another point about the SBAS service is it comes from satellites that are geostationary above the equator. And so the further north you go, the harder those satellites are to really pick up and get a reliable connection. Okay, back to you, Gianmarco.
Thank you, Dave. Let me add also on my side, same kind of test that we did in a drive test for one customer in Europe, where he wanted to see the performance of the DGNSS, and also here we are slowing down 1 second versus 30 seconds. And I believe this is what the majority of the customers will experience in their day-to-day tests. What we can highlight here is the SY-D with the DGNSS is consistent even at lower update rates. So if you see at 95% of the accuracy at 1 second or 30 seconds is still within 1.5 meter for an urban within a town, I would say, with mixed environment, so blockage, drive test. So it's really a very common use case, and that is, I would say, not even a very it is a very common use case, but what it can be highlighted here is that even at lower rate, the performance are consistent. And what makes the difference of the Skylark Dx versus, let's say, not using that is what a live test that we did, where we have a classic example in a traffic light under a foliage canopy in a town, so with blockage next to it. And if you look at the purple, the blue line is the reference. The purple line is one competitor that is struggling with what is called static wandering. That is a very common phenomenon at traffic lights, where the position is calculated multiple times and the module tends to shift a little drift. Well, the green light is the SY-D without corrections, and the yellow one is the SY-D with your DGNSS corrections. So the application of these corrections in a real use case can improve the accuracy, I would say, in the outliners, or in the in not in the average, but in the very difficult cases, improving the accuracy by 0.5 meter or more. So I think this is all from the GNSS part, and I think Dave is back to you on the RTK.
Sure, thank you. Okay, so Skylark Nx RTK, this is our regional network RTK solution. So we have, again, similar coverage areas, but we operate with our partners. This is delivered via IP. Same constellations, GPS, Galileo, Beidou, L1, L2, L5. And we serve the RTCM MSN5 messages, which have the RTK components with Dopplers. So this is a very common format for DGNS for RTK corrections. So similar picture, we have wide coverage area. This is a regional service, so you have to be within a certain distance of our base stations for to get the highest accuracy. And this is a service we have up and running today. And now Gianmarco is going to walk through some of the results that we are getting with the RTK module, and yet some of them are just quite incredible. How accurate this solution can be. Okay, so thank you. Over to you.
Thank you, Dave. Yes, let me present a first slide with the static results. We managed to obtain with our SE868K5-RTK product, for which that will be actually the samples are already available, but will be mass production right at the end of this month. So this is still the preliminary results. So I apologize if we are missing something, but this is our latest version candidate, I would say, for the mass production that we are working on. And I wanted to highlight this performance as soon as possible. On the left side, we see a 24-hour static test. And in this case, we can see that the accuracy over 24-hour as the 90%, let's say, of the results are below 1 centimeter accuracy, while even if these results are great in a 24-hour, let's say, test, even a very short test, a couple of, so let's say 15-minute test, compared with, I would say, high-end competitor, shows that our latest beta is almost aligned with the performance of what we would say that it's an established product on the market. And we are able to achieve 1 centimeter accuracy. Let's say it's 95% would be around 2 centimeter, but let's say that the number sticks to itself. On the also on the RTK side, our application engineering was playing with our evaluation kit and moving our antenna for writing down the Telit Cinterion logo, that at least the letters written down in a 30 centimeter wide letter. And as you can see, measuring the length, we are able to measure a real case would be 30 centimeter here. So as you can see, and the measure value from this point to this point is actually 30.39 centimeters. So I'm really we're really happy with the current performance of the product. It is showing promising results, and we moved from, let's say, the static in-house, the result that just came in last week. The performance we managed to get in just this month were on the real test. Again, so that will be a drive test. We are almost, I would say, of course, by eye with the pictures is almost impossible to see the shift of the modules from the reference. But again, we compare and our performances versus the I would say the state of the art of the competition, and on average performance, we are absolutely there. Although we still need to improve a little the max error there, but our team is working on it. So this is all these results are achieved using the SE868K5-RTK and the Skylark Nx RTK. On that side, I've got a short video showing, in addition to how to the proposal, let's say, workflow of using our GNSS AVK and cellular module to connect to Skylark service. We also offer a testing tool that can see. Trying to start it here, yes. And here it is. So if you see here, we have got a Sony-based SE868SY-D module, so L1, L5 dual frequency module that is achieving also, let's say, in our test is achieving a CP of 3 meters about. We are connecting through our Entrep client panel in the testing tool to the Skylark DGNSS service. Yes, here you can see, click start, and then once we receive the corrections and we refresh the we refresh the panel with the statistics, you can see that the CEP is decreasing almost instantly, and within, I think it's much as it 10 seconds, 20 seconds, we already are below at 0.8 CP. So that is showing that the module can clearly within seconds get down to achieve this kind of accuracy. And finally, I think it's my last slide here. Just an example here of our setup. For that is just a demo we did for one customer. So we connected our RTK module to our cellular module using our SIMs, and we developed a couple of customized commands for connecting to the SwiftNAS server. And as you can see here, for the DGNSS, there is, okay, of course, the server and username and password, and similarly for the Skylark Nx on that side. I think that's all on my side. I invite you to try our services, our modules, together with SwiftNav service, and I get back to you, Amanda.
Great. Thank you so much, both of you, for that presentation. Real quick before we get to the questions, audience, I'm going to drop a poll on your screen now. If you would like to have one of our experts contact you directly, maybe you have some questions specifically to your application, please just respond here on the poll and we'll be sure to have somebody reach out to you. All right, we have gotten a couple questions, so I will just dive right into these in the few minutes that we've got left here. First question, if I want to test the performance of DGNSS or RTK, what do I need?
I can take it. Then David, maybe you can add your comments on it. I think the easiest way is to register to the poll and ask for an evaluation kit. So our sales team will be in contact with you for providing an evaluation kit. And as I was showing before, the evaluation kit can either be tested with our testing tool, TelitView, that can be downloaded from our website. And I also invite you to register to Swift Navigation website. You can find the registering page on the resources, on the webinar resources. And together we can allow you to have a trial of our modules with Swift Navigation services to test whatever is, depending, of course, on your accuracy need and high precision needs. I don't know,
Yeah,
David.
absolutely. So once, if you want to try this, we want to make it as simple as possible. So when you have the evaluation kit, we can provide a free trial period so that you can test both our NX RTK and our DX DGNSS stream. Thank you.
Great, thanks guys. Next question we've got here. What would be the expected data requirement for the DGNSS and RTK solutions?
Okay. Again, do I take it and then Dave, you add on top?
Sure.
Okay. So that really depends on the use case. Because of course, on the RTK side, that is more, I would say, data consuming. An intensive use can be in the order of gigabytes per month. So even several gigabytes if the module is always on, depends on the use case. On the DGNSS, instead, let's say the data, the amount of data is less, but also the frequency of the connections, so the rate of the connections and the amount of time the module should stay on also affects. So I think we can range to few tens of megabytes per month for average low rate use case, up to maybe even 1 gigabyte or so if you really want it 24-hour on with all the corrections on. So it really depends. So I'm happy to follow up with this question later on if a customer has specific use case and we can tailor the exact amount of data that will be needed.
Yeah, I think that's completely correct. I mean, one way to view this is higher accuracy always has some level of cost, be it hardware, antenna quality, and for the corrections feed. If you want centimeter accuracy all the time, then that's quite a lot of data because you're streaming the RTK services. But if you have a asset tracking tag and you want submeter and maybe it reports in a couple of times each day, that can be very efficiently done with a single packet of DGNSS aiding. It's valid for 30 seconds. And that's a very data efficient solution, but lower accuracy. So it's really finding that balance where you really want to operate on the curve. Okay, back to you.
Yeah, great. This looks like a two-part question here. So what is the expected power consumption of these modules? And what about the cellular part?
As I was mentioning before, on the RTK GNSS module, the SE868K5-RTK, the power consumption is around 70 milliwatt at 1.8 volt, while on the DGNSS we can go down 30 milliwatt. So depends on how many constellation, depends on the use case, but let's say ballpark that will be let's say below 50 milliwatt at 1.8 volt power consumption. However, the majority of the consumption will be on, I would say, on the cellular part. That can be quite consuming. That really, again, I think on the LTE, it can be surely in the order of several hundred milliwatt. but needs to double check if the audience can follow up and let us know exactly what customers or what they are looking for. I can get back with more precise consumption on the LE910 or the ME910. That is a Cat-M product that probably has better consumption than an LE910.
Yeah, great. Next question I've got, which protocol or format do the Telit modules support to achieve high accuracy? Looks like you mentioned RTCM.
Yes, okay. I need to leave some to Dave as well. Anyway, yes. So the SE868RTK, so K5-RTK supports from MSM4 to MSM7. Although with Skylark and SwiftNav, at the moment we are testing and focusing our effort on the MSM5, while the SE868SY-D is instead supporting RTCM MSM1 messages. So they are both RTCM, I would say 3 is the, David knows better than me, is
Yeah, no, that's completely correct. It's RTCM 3.2, and for DGNSS, it's the MSM1 multisat message group 1. And on the RTK side, we use MSM. We can supply MSM4 and MSM5. MSM5 is the one we've been focusing on here. MSM7 has a lot of, is a higher resolution set of aiding that can be used for millimeter applications, and generally that's not relevant for these types of applications. So we don't support that currently. We could, but it's not really a fit with sort of mass market type applications. Okay, Amanda.
I think I'm going to take just one more question here. We're coming up on the hour. Is mtrip client mandatory for downloading corrections?
No. We presented you the ntrip because it is the network transportation for RTCM over IP. So it's actually the standard, a standard for providing RTCM type corrections to the module. As long as the module receives the RTCM type corrections, it is not really relevant how you provide them. But since this is the standard and that is what is supported by SwiftNav on current products, that is what we implemented also in our demo app for the cellular side and inside our TelitView testing tool.
Yeah, and to add to that, while we support ntrip today, we are as the market evolves, we are evaluating different methods of transport for corrections, and one of those, for example, is MQTT. So we are directly talking with Telit in depth about what that could look like in the future. So we do expect to broaden out past ntrip as the standards and the markets evolve.
Great, guys. I believe that's all the time that we have for today. Audience, please be sure to check your inboxes in the coming days for that replay link. Again, we talked about a lot of the resources that are here in the resources section that is located on your screen. Gianmarco, Dave, thank you so much for your time today, and thank you everybody who joined us.
Okay, thank you, Amanda.
Thank you, Dave.